Welcome back, folks. This is the second of two videos on probability, and today's video is talking about this situation here where Biff is a senior at IGO School Academy. So these are very complicated examples, and so I'd like to kind of explain it a little bit more fully. What's going on is that Biff is applying to three different universities, and as you can see down below here, it says the acceptance probabilities for Biff are these three. So Biff has a 0.2 chance or a 1/5 chance of getting into the first academy or the first college, 0.3 and then 0.4. One of the things that people make mistakes at, if I ask the question like, what's the probability that Biff does not get into any of the three, they take 1 minus the sum of those, which is 0.9, and they get 0.1. And that's actually not correct, or not necessarily correct. You can't just do that in the sums, because when it says the probability of A, it doesn't mean the probability of only A. It could be some overlap. So if that's the case, we need to do a good job of drawing a fairly decent picture of this. So I'd like to just do that here. I'm going to draw a nice Venn diagram of our situation where A is the first college and B is the second college and C is the third college, and we'll see what we can do with that. So we'll put an A here, a B here, and a C. And next to each one, keep in mind that the 0.2, which is the chance of him getting into the first college, 0.2, applies to the entire circle. And this is 0.3 for B. That applies to that entire circle. And C is 0.4, and that applies to that circle. Now, there's one really tricky spot in this problem, and it's number 5 right here. But actually, number 5 is a great clue. So let's take a look at some of the other ones that give us some nice clues. I like number 6 here. The probability of all three. That's this guy right in the middle, 0.05. So we can put that in there right away in that single cell. Look at number 7, the probability of exactly 2. Now, where is that located in the picture? That would be exactly these two, but not all three, exactly these two, but not all three, or exactly these two and not all three. So that's going to be a really tricky one because that's a three-compartment probability, which is a very tricky one there. All right, so a couple of other things that we see. It says, number 4, the probability of A and B, which is this entire football right here. But because we've already got the 0.05, we can just put in the other 0.05 right here. That adds up to 0.1. All right, so that's the first one. So let me show you this tricky part, this part right here. It says the probability of B or C. That's this right here. This whole thing right here. Okay? That whole thing has to add up to 0.6. But notice if you add up the probability of B plus the probability of C, you get 0.7. So there must be some overlap. And as it turns out, excuse me, that probability of C is 4. That should be a 0.4. And when you add them together, you get 0.7, which is an overlap of 0.1. And that's your clue. It says that the entire grouping should be 0.6, not 0.7. So let me back this up a little bit and realize now that this must be, in order for this to be a total 7, we must have a 0.05 here as well. Now let me see if I can explain this properly. That entire football right there has to be 0.1 because the overlap between the 0.4 and the 0.3 is 0.1. Okay, so 0.7 is what the total amount is between probability of B and probability of C minus the overlap, which is 0.1, should equal the OR statement, 0.6. That's a little computation that I did on the side. That's a tricky one. Anyway, it does give us a little clue because now we can just go around the horn and get all the rest of the answers. So for example, we can now find this one. Exactly 2 is going to be 0.2. So I add my 2.5s and this 0.1 over here. That should give me my 3 little cells to make 0.2. And notice that in section A, the circle has already been filled. So this is going to be 0. So in other words, A is not, it doesn't exist that he only gets accepted to A. Which makes perfect sense because if the probability of getting to A is very small, then if he gets into A, he probably got into one of the other two as well. Makes logical sense. Over here, this is going to be a 0.15 if I add those all together to make the 0.3. And now my last part over here, 0.2, in order to get that to work out as 0.4. All right, I only have one thing to erase, and that's this little thing right here. That doesn't have anything to do with it. Now notice that in this case, if I add all of those probabilities up, that's 0.15 plus 0.05, another 0.05, another 0.05, a zero point 0.2, and a 0.1, I end up with 0.6 as my answer. Okay, that's 0.6. That's everything added up. That means that the probability that he does not get accepted into any other place has to be 0.4 because this model has to add up to one total. All right, so there you go. That just goes to prove that we are still at school because the bell is ringing in the background. So let's just go through these answers now. Probability of no acceptances is 0.4. Excellent. Probability of only A is going to be 0, and the probability of only B is going to be 0.15. Okay, so the answers come out real easy once you do all the analysis in the Venn diagram. So hopefully this will help on the example that I gave you for this second part.